Hello everyone, I am Rama. In this lecture, I am going to show you how to get the iterations in Gauss-Seidel method to solve a system of linear equations using the calculator Casio fx9n1us plus. Let us see an example. Find the approximate solution of the system of linear equations 20x plus y minus 2z equal to 17, 3x plus 20y minus z equal to minus 18, 2x minus 3y plus 20z equal to 25 by Gauss-Seidel method. It is very clear there is a guarantee for the solution in Gauss-Seidel method if the system of linear equations are diagonally dominant. It is very clear the system of equations are diagonally dominant. The given the system of equations can be represented in the matrix form as shown in the box. So in this we can see the diagonal elements 20, 20, 20. These elements are satisfying the condition that modulus of diagonal element is greater than or equals to sum of modulus of other elements in the same row, so that the given system of equations are said to be diagonally dominant. So that the iteration formula for Gauss-Seidel method can be written as, we need to take the coefficients of dominating elements from each equation. So that let us take the first dominating element 20, its coefficient is x. This x is to be written from first equation. From this x is equals to 1 by 20 into 17 minus y plus 2z. And here another dominating element along the diagonal, its coefficient is y. This should be written from the second equation. Y is equals to 1 by 20 into minus 18 minus 3x plus z. And the next diagonal element is dominating diagonal element is 20, its coefficient is z. It is to be written from third equation. From this z is equals to 1 by 20 into 25 minus 2x plus 3y. This is said to be the iteration formula for Gauss-Seidel method. Here we need to take initial guess for two variables y and z, so that the iteration for x can be obtained. Now that can be used immediately in the next equations wherever the variable is appearing. And in second equation we can see that apart from x there is z. For z no improved value will be available, so that the initial guess which is taken is to be used. Then using x and z values here, the first iteration of y can be obtained. After getting this improved value, in the next equations we use this improved value wherever it is appearing, so that in the next equation we can see x and y on RHS part. For both the variables improved values are available. They can be substituted here to get the improved value of z. In a similar way, the same process can be repeated till we get two successive iterations are same up to the desired accuracy. In this problem, the initial guess is not given, hence we can take the initial guess for both y and z can be taken as 0. If this is given in the problem, we need to use those values. Hence, the successive iterations for the variables x, y, z can be obtained as shown in the table. By giving y, z 0 in the first equation, the next value is obtained as 17 by 20, which is nothing but 0.8500. Now x and z variables are appearing. For x the improved value is available, and for z no improved value is available, so we use the initial guess. By using the two values, we get the first iteration of y as minus 18 by 20, which is nothing but minus 1.0275. So that the first iteration of y is been obtained. In the next equation, we use the first iterations of x and y are used, so that the first iteration of z is obtained as 1.0109. All these values are taken up to 4 decimal places by rounding off the values of x, y, z up to 4 decimal places. Now we use the first iterations to generate second iterations and so on. Let us see how to get these iterations in calculator. In Gauss-Seidel method, we use only 3 variables to type iteration formula in calculator. So in this iteration formula, yk plus 1 is taken as y, zk plus 1 is taken as d. As that is not available in the calculator, we take it as d. For xk plus 1, we take x. So that this formula is to be entered in the calculator as x equal to, or x is here, alpha x equal to 1/20 into 17 minus y alpha y plus 2z is nothing but 2d, brackets closed, colon. Next equation is y equal to alpha y equal to 1/20 into brackets closed, brackets open, minus 18 minus 3x plus z is nothing but d, alpha d, brackets closed. To enter third equation, colon, and z equal to, in the sense d is equals to 1/20 into brackets open 25 minus 2x plus 3y, 2 alpha x plus 3y alpha y, brackets closed. We have typed all 3 equations. Now press this CALC button. We see y question mark. We need to enter the initial guess what we have in the problem. Here the initial guess is taken as 0, so we should enter 0 here and then press equal to. Then we see d question mark, in the sense z value. For z also the initial guess is taken as 0. We give 0 and then press equal to. Then we see x value as 0.85. Note down the value and press equal to. So we are converting this to decimal. We see the value as minus 1.0275. Again press equal to and converting to decimal. We see the value 1.010875. Rounding this value to 4 decimal places, then it can be taken as 1.0109. So we have taken all the first iteration values. So to get second iterations, press equal to. Then we see y question mark. In this method, we give the values for y and z for the first time only. For this we use only the initial guess what we have in the problem. Later, no need to enter the values of y and z to get next successive iterations. So that's what we will see here. We see y question mark. We can see something here. Let us convert this to fraction, where we can see minus 1.0275. This is what our first iteration. I did not enter any value here. Press equal to d question mark, converting this value to decimal. Then we can see 1.01087, nothing but that is taken as 1.0109. So whatever the first iterations of y and z we have already entered, they can be seen on the display when we are using equal to button. Now we press this equal to button so that the values of x, y, z can be obtained. X is obtained as 1.00246 something. This can be rounded to 4 decimal places so that the value of x is taken as 1.0025. Again press equal to, we see y value, we have minus 0.999825, rounding off to 4 decimal places. This can be taken as minus 0.998. Again press equal to, we see d value, again rounding off to 4 decimal places, we get the value 0.998. So these are the second iterations. To get the third iterations, press equal to, we can see y value on the display, which is nothing but the second iteration. Again press equal to, we can see the second iteration of z on the display. I did not enter second iterations here. So after this, we get the values of x, y, z, for which press equal to. We have x value 0.4969 something else. Rounding this number to 4 decimal places, then it can be rounded to 1. This is rounded off to 1, nothing but 1.4 zeros. Again press equal to, we get y value which is minus 1.50 something, taking the value up to 4 decimal places. The value is minus 1. For next variable, we press equal to, converting this fraction to decimal, we get 1.50 something. We are taking up to 4 decimal places, 1.40. Again we can see the next successive iterations also. There we can see that the values of x, y, z are 1, minus 1, 1. So by observing the iterations, we can say that x values are tending to 1, y values are tending to minus 1, z values are tending to 1. So the solution of the given system is 1, minus 1, 1. I hope you understood this. Thank you.